Hi students, in this video we are going to look at how to anti-differentiate a trigonometric function. So we are going to establish a couple of rules and use them for integrating or anti-differentiating trigonometric functions, sine and cos in particular, and then do some examples involving adding some functions, functions made up of multiple functions added together, and also anything where our function can be expressed in terms of some linear component. Key things to remember: anti-differentiation is the opposite or inverse of deriving. When carrying out anti-differentiation, we always need our constant of integration. Right, so that's C. And remember our derivatives of trigonometric functions. So derivative of sine is cos, derivative of cos is negative sine. You might remember also seeing we often draw a little table like this: negative sine x, negative cos x, positive sine x, and we'd say that going down this row, that's how we derive our trigonometric functions, just by going down that list. All right, now let's do an example where we have to derive and then see again how we can do anti-differentiation, do it in reverse from what we, from applying the process we just worked on, but in reverse, obviously. So determine the derivative of 2 sine 5x minus 1. So if we have to find f dash x, well, how we know for this one, derivative of sine is cos. So it becomes 2 cos 5x minus 1. And then we also know that we have to multiply by the derivative of what's in brackets. So multiply by 5. And so that will give us a final answer of 10 cos 5x minus 1. All right, so the key step we had to do here, well, there were two key steps really, when we had to derive this function. Sine had to change to cos, and we also had to multiply by 5 because that was the derivative of what we had here in brackets. So when we want to integrate or anti-differentiate this function here, f of x is going to be our integral of 10 cos 5x minus 1 dx. That's going to equal, oops, don't need that. Okay, first of all, the cos has to change to a sine. So that sort of makes sense. If we have sine x and cos x, if we know that when we derive we have to go down, well, when we integrate or when we anti-differentiate, we need to go back up in the opposite direction. So the cos needs to change to a sine, so that'll be 10 sine 5x minus 1. And then again, we multiplied by 5. So instead of multiplying by 5, this time we have to derive by 5, just like we did with our exponential problems. Instead of multiplying by the derivative when we're deriving, we're dividing by the derivative of what's in brackets when we are anti-deriving or anti-differentiating. So 10 over 5, that will give us 2 sine 5x minus 1 plus c, which matches up with what we started with. So our key steps are changing sine and cos backwards and forwards, or backwards, according to our differentiation rule. And then dividing by the derivative of what's in brackets. Right, so in our general cases, it might be worth considering, going back to our table before we consider our general cases, how our table works. So when we had to change from sine to cos and so on, we derive or differentiated by going down. If we are integrating or if we're anti-deriving, we will go up the list. So if we're anti-differentiating, we will go up the list instead of down. So if we have to integrate a sine bx minus d dx, that's going to equal, first of all, sine is going to change to negative cos when we're anti-differentiating. So sine's at the bottom, so going up it will become negative cos. So negative a cos bx minus d divided by the derivative of what's in brackets. Well, we've got derivative of bx minus d, that's just b, so we'll divide by that, plus c, our constant at the end there. All right, for cos, that'll be a cos bx minus d dx. All right, so cos will change to positive sine, so that'll be a sine bx minus d divided by b, again, plus c, because the derivative of what's in brackets, bx minus d, is going to be whatever value b is. And so those are our general rules. So always just change according to whether you're moving up or down in this list, and then divide by the derivative of what's in. All right, so we've got a couple of examples to do here. We've got 5 cos 3x plus 1. I'll just write out my little table here. Sine, cos, negative cos, sine. All right, so we've got 5 cos, oh sorry, let's just do our integral. 5 cos 3x plus 1 minus 8x dx. So 5 cos, when we go up, we'll change to sine 3x plus 1 divided by 3 minus, this is a power function on the end here, so 8x, the power will go up to 2, divided by the new power, plus c, so that's going to be 5 thirds sine 3x plus 1 minus 4x squared plus c. This is my derivative in this case. All right, for this next one, this one at the bottom, my integral of negative 3 sine 5 minus x dx. Students, so I'll note in this one here, just be wary of it all of the time. When you're using your integral notation, make sure you have your elongated s at the front, but also the dx at the end. It's important to have that there. That is a key part of our notation. All right, that's going to equal now negative sine. Right, so we have a negative sine curve here, negative 3 sine x, but still negative sine. So when we integrate, we'll go up to cos, or positive cos even. So that'll be 3 cos 5 minus x all over, and then the derivative of the power, or the derivative of 5 is 0, derivative of negative x is negative 1, plus c. So my antiderivative is going to be negative 3 cos 5 minus x plus c. And there we go. Right, so guys, after watching this video, you should be able to anti-differentiate sine and cos functions.